All right, now let's go ahead and talk about rectangles. So rectangles are actually a very easy thing when you already know parallelograms because you only add two really basic properties. So basically one of them is that all four angles, okay, let's show red pen. All four angles are right angles. So let's go through and make sure we have a picture of it. So I'll just do a vertical one. No big deal here. So this has basically everything going on here that our other one did. So we have our opposite sides being congruent, so we'll make sure we show that. We have the parallel. Since I have more space, this will be the one with two. And then I have all right angles now, so I'm going to put right angles in here. Alright. And then the last thing that we need to make sure that we do is that something new is that both diagonals are equal. So what we have, and I'll put letters on here, A, B, C, and D. So what we have is actually they still bisect each other. So they cut each other in half. Then they're exactly the same size. Alright. Now one thing to recall here, so I'm actually going to write that AC is congruent to BD, because that's new. The rest of it was given to us already. The bisecting, we already knew. Now, something that's actually really important here is that because we have right angles, if I highlight right here, triangle BAD, you should notice that you have a right triangle. So it's possible that we might need to answer some questions by doing, how come I get right triangles? What was that thing again? Oh yeah, the Pythagorean theorem. We might need to do that. All right. Now, for example number 1, we actually still have the idea of alternate interior angles. So we're going to do alternate interior. So if I have 27 right here in this corner, I know I actually also have 27 in this corner. All right. Now what's really nice about that is actually there's a pattern. So we'll always end up with two triangles that are exactly the same and then another set of two triangles that are exactly the same. They're isosceles. So we have 27 here. And we have 27 here. And then we get to use the fact that this is a 90-degree angle. So these are all 90. So what we're going to do is we're going to subtract from 90. So we'll do 90 minus 27. And that's going to get us 63. And in all of these corners here, they're going to be 63. It's always nice knowing what they add up to because then it's just a little bit easier. So let's go through and let's talk. It says the angle MJK. So MJ to K is the entire corner of K. So that one is 90 degrees. Then it says MJL. So it's asking you to cut it off part way. So MJL is 63 degrees. Then it says JLK. So from J, follow down to L, and then K. That one's also 63 degrees. Then we have KML, so from K down to M and then to L, that's 27 degrees. And then we have MNL. We haven't done that one yet. But if we look right here, we have a triangle, and all triangles add to 180. So we could do X plus 27 plus 27 equals 180. So we have X plus 54 equals 180. And then we'll just subtract. So if we subtract, we should get 120 Alright? So I'm going to pause and let's see what you can do about number 2. Let's see what you can do with number 2. So pause. Alright, so I have a feeling this is as far as we got. So we have AC is 30. We have BD, which is also 30. That's our two diagonals. And then we have BE. BE is part way, and that's 15. And then we have AB, which is 27. Then they ask us about BC, but we don't know what BC is. But we do have a right triangle, so we can find it. So because we can find it, the only way to find it is going to be using the Pythagorean theorem. So let's do that. So the Pythagorean theorem, let's go. So this is x. So our hypotenuse is 30. It's going to go 30 squared equals, then we have 27 squared plus x squared. So 30 squared is 900. 27 squared is 729. And then we have plus x squared. Now let me double check that. Alright, and now we're going to subtract. So we get 171 equals x squared. And then we're going to do square root. Now we're going to need to factor through 171. So let's see what happens. I think it divides by 3. So 3 and 57. Let's try dividing by 3 again. We get 3 and 19. So our here, right here, is 3. And then we have a 19. So it will be 3 square root 19. Great. Now let's check the next one. So it says DB is 42, so we'll need to cut out in half. 21 and 21. It says AD is 26. So we know this one is 26. Oh, and these are both 21 as well. And then it says DAE is 52. So DAE is 52, which makes this one 52, which actually also makes this one 52, and this one 52. Find the other ones on the outside. I just need to subtract 90 minus 52. That's going to get us 38. And all of these will be 38. 38. 38. Now go through and see if you can answer these. So I'm going to pause and do them myself. Alright. Now the only thing that we're missing is, again, the part where we need AB. So AB is the part here. So again, we're going to need to do the Pythagorean theorem. This should not be new. We should know this. Okay? So AB is going to be our x, and it's a leg. So we have 42. I'll put it here. 42 squared equals 26 squared plus x squared. So 42 squared, and I would use a calculator for this, is 1764 equals 676 plus x squared. Now I'm going to subtract, so minus 676 is 1088. And now we're going to need to go through and do a factor tree. I don't have any room, so we'll do 1088 over here. It divides by 2. That gives me 544, so 2 and 544. This one also divides by 2, so divide by 2. 2 and 272. This one divides by 2. 2 and 136. Divide by 2 again. And 68. This is 2 and 34. And 2 and 17. Perfect. Almost ran out of space. So we're looking for pairs. So here's a pair of 2. Here's another pair of 2. And then we got one going across here. Another pair of 2s. And then we have a 17. So that gives us 2 times 2 times 2 times 17, which is 8 square root 17. Alright, so now what I'm going to do is I'm going to do the rest of it for the next couple, and I want you to just... Alright, so I went through and did that for you. So number 6, actually it looks like the letters were slightly off, so just make that R a W, and then it should be very simple to complete. So one thing that I did have to do here is it says VW, which is just part way across, is 9x minus 11, and SU, which is all the way across. So you need 2 WVs, that's why I have 2 times 9x minus 11, equals the entire thing. So 2 parts makes a whole diagonal. So 2 times 9x minus 11 equals 16x minus 12. And then, because they wanted the whole thing from W to T, I just plugged in for SU because they're exactly the same size. All right, thanks.